Most people hear the phrase pond scum and immediately think of something useless. Slimy. Dirty. Something nature forgot to clean up. And that reaction alone might be the biggest reason one of the most nutrient-dense food sources on Earth has been hiding in plain sight for decades. Here's the part that usually stops people mid-scroll. There are aquatic plants, yes, the green stuff floating on stagnant water that contain more protein per gram than beef rival soy without the industrial baggage, grow faster than almost any crop on Earth, and require virtually none of the inputs we've been told are non-negotiable for food production. No soil, no fertilizer arms race, no feedlots, no antibiotics, no massive land footprint. And yet almost nobody is eating them. I'm not saying this as someone who just read a headline or watched a documentary last week. I've been tracking these plants for years, watching the hype cycles come and go, watching superfoods get inflated, monetized, diluted, and forgotten. I've read the papers, followed the pilot programs, talked to growers, tested the powders, compared amino acid profiles, and looked very closely at who benefits when certain foods stay invisible. This isn't a miracle pitch. There's no magic bullet in nutrition, but there are blind spots. And pond-based protein is one of the biggest ones we've got. The primary plant I want you to remember in this video is duckweed, especially varieties like Lemna minor and Wolffia globosa. That's our main character, but it's not alone. It belongs to a quiet group of aquatic plants often lumped together, misunderstood, and dismissed that punch. So far above their weight nutritionally, it almost feels like a glitch in the system. Duckweed can double its biomass in as little as 48 hours under the right conditions. That's not marketing hype, that's been documented repeatedly in controlled environments. Compare that to cattle, which take years to reach slaughter weight, or even soy, which requires months. Heavy inputs and massive monocultures just to function at scale. Protein-wise, dried duckweed can reach 40 to 45% protein by weight, with a surprisingly complete amino acid profile. Not perfect, but closer than most plant proteins people actually eat. In some comparisons, it rivals or exceeds beef gram for gram once you remove water weight and account for usable protein. So the obvious question becomes uncomfortable very quickly. If something this efficient, this dense, and this scalable exists, why don't we hear about it? The answer isn't that it tastes terrible. It doesn't. Prepared properly, it's neutral mild, almost spinach-like. It's been eaten traditionally in parts of Southeast Asia for generations. In Thailand and Laos, Wolffia, sometimes called watermeal, is considered a delicacy. This isn't theoretical. This is historical. The answer also isn't safety. Duckweed has been extensively studied for human consumption, animal feed, and even space missions. NASA has researched it as a potential food source for long-duration space travel because of how absurdly efficient it is. The real answer is more boring and more frustrating. It doesn't fit the existing food narrative. Industrial food systems are built around infrastructure, land ownership, processing pipelines, subsidies, supply chains that favor predictability over efficiency. Duckweed breaks that model. It grows too fast. It doesn't need farmland. It doesn't slot neatly into existing commodity markets. And because of that, there's no massive corporate lobby pushing it into your grocery store. Instead, it gets labeled as pond scum, and the conversation ends right there. But duckweed isn't the only one. Another overlooked aquatic powerhouse is Azolla, sometimes called mosquito fern. It's famous in agricultural circles for its ability to fix nitrogen naturally, but nutritionally, it's far more interesting than people realize. Dried Azolla can reach protein levels comparable to legumes, along with a dense micronutrient profile that includes iron, calcium, and beta-carotene. Then there's spirulina, which technically isn't a plant but a cyanobacteria often marketed heavily, often overpriced, and often misunderstood. When grown cleanly and processed correctly, it's legitimately nutrient-dense. When mass-produced poorly, it becomes just another overhyped powder with diminishing returns. I've tested enough brands to tell you the difference matters more than the label. What all these organisms share is speed, efficiency, and independence from traditional agriculture. And that combination makes them disruptive in a way most superfoods never are. Now, before someone jumps in and says, if this was so amazing, everyone would already be using it, let me stop you right there. That assumption has been wrong more times than it's been right. Nutrition history is full of examples where effective low-cost solutions were ignored because they didn't align with profit structures or cultural bias. Oats were animal feed before they were heart-healthy. Sardines were poverty food before they were omega-3 gold. Even potatoes were once considered dangerous. Food acceptance isn't driven by nutrition, it's driven by narrative. And duckweed has had the worst narrative imaginable. In the next section, I want to break down exactly how duckweed stacks up against beef, soy, and other protein sources, not in marketing terms, but in real, measurable ways: protein density, amino acid completeness, growth efficiency, environmental cost, and scalability. But before we do that, I want to hear from you. Have you ever come across a food that sounded ridiculous at first, but turned out to be far more legit than you expected? Or have you ever bought into a superfood that completely failed to live up to the hype? Drop it in the comments. I read those not just for engagement, but because that's where the real pattern recognition happens. And if you want sources, studies, and deeper breakdowns as we go, I'll have those linked in the description so you can dig in yourself. Nothing here is hidden. Nothing is paywalled. Because once you see how this actually works, it becomes very hard to unsee. When most people compare protein sources, they do it in the laziest way possible. They look at a nutrition label, see a number next to the word protein, and stop thinking. That's not how this works. That's never how it's worked. If you've spent any real time comparing food systems instead of food products, you learn quickly that where protein comes from matters just as much as how much of it exists on paper. So let's slow this down and do it properly. Beef is often treated as the gold standard: high protein, complete amino acids. Cultural prestige. Strength mythology baked into the marketing. But beef is also about 70% water by weight. Once you account for that, the actual usable protein density drops significantly. Then you factor in feed conversion ratios, land use, methane emissions, antibiotics, water consumption, and the sheer time it takes to turn grass and grain into muscle tissue. This isn't an anti-beef rant. I've eaten beef my whole life. I still do. But pretending it's efficient is a fantasy. Now compare that to duckweed. Duckweed grows directly as edible biomass. No bones, no hide, no waste tissue. When you dry it, you're left with a product that can reach 40 to 45% protein by dry weight. Not theoretical, not cherry-picked, repeatedly documented. And unlike many plant proteins, duckweed's amino acid profile is surprisingly balanced. Lysine, often the weak point in plant-based proteins, is present in meaningful amounts. Methionine is lower, yes, but not catastrophically so, especially when combined with other foods. Here's where things get uncomfortable. If you measure protein per acre per year, duckweed doesn't just beat beef. It obliterates it. We're not talking marginal gains. We're talking orders of magnitude. A small controlled water surface can produce more usable protein annually than multiple acres of grazing land. And it can do it continuously, not seasonally. This is the metric nobody wants to lead with. Because once you do, the conversation shifts from what do people like to eat to what actually feeds people efficiently. And that's a very different discussion, one that doesn't benefit entrenched systems. Soy often gets brought up as the counterargument. We already have a high-protein plant crop, people say, and yes, soy is protein-dense. But soy also comes with baggage: monoculture farming, heavy pesticide use, soil depletion, processing requirements, and in many cases, genetic modification designed for yield, not nutrition. Duckweed doesn't compete with soy on soy's terms. It sidesteps the entire playing field. It doesn't need arable land. It doesn't displace forests. It doesn't require massive harvest machinery. It can be grown locally, harvested continuously, and processed with relatively simple infrastructure. That's not just efficient, that's destabilizing. And it's not just duckweed. Azolla offers a similar story with a slightly different profile. It grows fast, fixes nitrogen naturally, and has been used traditionally as both animal feed and human food. Protein content varies by species and growing conditions, but even conservative estimates place it solidly in the high protein category. More importantly, it brings micronutrients to the table that are often missing in protein-only comparisons. Then there's spirulina, which deserves a more nuanced take than it usually gets. When spirulina first hit the mainstream, it was treated like a miracle. Then it got commodified, cut, and overmarketed. The result is that most people either think it's magic or think it's useless. Both are wrong. High-quality spirulina is legitimately dense. Protein, iron, B vitamins, antioxidants. Quality control matters more here than almost anywhere else. Poorly grown spirulina can accumulate contaminants, Overheated processing can destroy nutrients. I've tested batches that were night and day different despite identical labels. This is where experience matters. Not all green powders are created equal, and pretending they are is how people get disappointed. Now let's talk about the elephant in the room: taste and practicality. No one is suggesting people start scooping pond plants straight out of a lake and eating them raw. That's a strawman argument that shows up every time this topic gains traction. In reality, these plants are usually dried, milled, blended, or incorporated into other foods. Think protein powders, pastas, baked goods, soups. Nutrient boosters, not novelty snacks. And this is where perception becomes the real bottleneck. We've been conditioned to accept ultra-processed foods with ingredient lists longer than a paragraph, but recoil at the idea of something that grows naturally because it looks unfamiliar. That's not rational, that's cultural programming. Let me put this plainly. If duckweed were discovered today in a lab instead of a pond, it would already be patented, branded, and sold at a premium. Instead, it's cheap, abundant, and unglamorous. Which brings us back to the original question: why is everyone ignoring it? Part of it is branding. Part of it is inertia. But a big part of it is that efficiency doesn't sell when scarcity is more profitable. Before we go deeper, I want to throw this back to you again. If you had access to a clean, safe protein source that grew faster, cost less, and required fewer resources, but it didn't come with prestige or hype, would you actually use it? Or would perception stop you? Be honest in the comments. That gap between logic and behavior is where most food trends live or die. The real reason foods like duckweed never break through isn't because they fail some nutritional test. It's because modern food systems don't reward efficiency unless it can be controlled. When something grows too fast, too cheaply, and without dependence on land ownership or heavy infrastructure, it becomes difficult to monetize in the usual way. That doesn't make it dangerous. It makes it inconvenient. Duckweed doesn't require farmland, and that alone removes it from entire subsidy frameworks that define what real food is allowed to look like. No acres, no lobbying. No spotlight. Most people assume regulation is about safety, but in practice, it's often about familiarity. Duckweed is approved in many regions, but approval is passive. There's no incentive to educate the public. No marketing engine turning it into a household name. No corporate voice explaining how it fits neatly into everyday life. Foods that thrive in the modern system usually arrive pre-branded, pre-processed, and pre-explained. Duckweed arrives raw, quiet, and indifferent to those structures, which leaves it stuck in a kind of nutritional limbo. The psychological barrier matters just as much as the institutional one. People don't reject duckweed because they've tested it and found it lacking. They reject it because the mental image of something growing on water triggers an instinctive response. It feels unsanitary, even when the data says otherwise. This is the same reflex that keeps insects off menus and keeps certain fermented foods from crossing cultural borders. Once a food is mentally categorized as not food, logic struggles to reverse that decision. What's ironic is that duckweed has never truly been absent. It's been present, just out of sight. It shows up in animal feed research because animals don't care about branding. It appears in wastewater treatment systems because it's excellent at absorbing nutrients. It's been studied in closed-loop environments, including space research, because efficiency becomes non-negotiable when resources are limited. These aren't fringe experiments. They're quiet validations happening away from public attention. And that pattern is familiar. Many of the most effective solutions don't enter culture loudly. They start in places where results matter more than perception. When something keeps showing up in those environments, it's usually because it works, not perfectly, not universally, but reliably enough to justify continued interest. The mistake people make is assuming that acknowledging duckweed's potential means replacing everything else. That binary thinking kills good ideas before they get a chance to mature. Duckweed isn't here to replace beef, or eggs, or legumes. It doesn't need to. Its real value is as a supplement, a booster, a way to add dense nutrition without expanding resource use. That's not radical, that's pragmatic. In practical terms, this means powders blended into existing foods, flours mixed into doughs, or protein additions that don't require people to fundamentally change how they eat. The goal isn't novelty, the goal is quiet integration. When people benefit without feeling like they've made a statement, adoption becomes easier. This is also where discipline matters. Not all duckweed products are equal. Growing conditions dictate nutrient quality. Processing methods determine what survives to the final product. Just like with spirulina or any other concentrated food, shortcuts show up in the results. People who dismiss the entire category after one bad experience are usually reacting to quality, not concept. If you're curious to explore it properly, resources are available, and I'll link them in the description. Not as a pitch, but as a reference point, because context matters when evaluating something this unfamiliar. Judging a food category by its worst example is how misinformation spreads. The bigger takeaway here isn't about duckweed specifically. It is about how many effective ideas sit just outside mainstream acceptance because they don't align with existing narratives. Efficiency alone doesn't guarantee visibility. In fact, sometimes it guarantees the opposite. Think about how many times you've ignored something simply because it didn't look the way you expected it to, not because you tested it, not because it failed, but because it didn't fit the story you were told about what was normal. That gap between evidence and acceptance is where most nutritional blind spots live. If you've ever changed your mind about a food after learning more than the headline version, share that experience in the comments. Those moments are usually where better decisions start, not just about food, but about everything else we assume we already understand. Over the long term, the value of plants like duckweed isn't tied to trends or headlines, it's tied to pressure. Food systems only change when they're forced to. And pressure is the one variable that always exposes inefficiency. Population growth, climate instability, water scarcity, rising input costs, these aren't abstract concepts. They're slow, grinding forces that make resource-heavy protein harder to justify year after year. When those pressures increase, solutions that once seemed strange start to look obvious. Duckweed fits into that future not because it's exotic, but because it's boringly efficient. It doesn't ask for ideal soil. It doesn't care about seasons the way terrestrial crops do. It doesn't collapse under heat the way many grains do. It thrives in conditions that are becoming more common, not less. That alone makes it relevant in a way many conventional protein sources aren't prepared for. What's rarely discussed is how adaptable these aquatic plants are across regions. They can be grown close to consumption points, reducing transport losses and energy costs. That localization matters more than most people realize. Every mile food travels adds cost, fragility, and waste. A protein source that can be produced near where it is consumed quietly solves multiple problems at once, without needing a technological breakthrough. There's also a misconception that future foods must be high-tech to be viable. Lab-grown meat gets framed as the inevitable answer, while naturally efficient organisms get dismissed as primitive. But sophistication isn't about complexity, it's about outcome. A system that produces usable nutrition with minimal inputs is sophisticated by definition, even if it looks simple. Duckweed's simplicity is deceptive. Under the surface, it's a highly optimized biological machine. Rapid cell division, direct nutrient uptake, minimal structural waste. It is doing exactly what evolution favors when resources are limited, converting available inputs into biomass as directly as possible. That's not accidental. That's selection pressure at work. As food stress increases globally, the conversation around protein will shift from preference to practicality. When that happens, metrics like protein per acre, protein per liter of water, and protein per unit of energy will start to matter more than branding. That's when overlooked systems tend to resurface. The irony is that adopting these foods doesn't require abandoning existing diets, it requires expanding them. Adding efficient sources doesn't mean subtracting cultural ones. It means creating buffers. Resilience comes from diversity, not replacement. And this is where the opportunity lies, not just for individuals, but for communities that are willing to experiment before necessity forces the issue. Early adoption isn't about being first for the sake of novelty. It's about understanding what scales when conditions change. If you're watching this and thinking, this sounds interesting, but it's not practical right now, that reaction is understandable. Most shifts don't feel practical until they suddenly are. The difference between those who adapt smoothly and those who scramble is usually familiarity, not access. That's why exposure matters. Knowing these systems exist changes how you evaluate the future. It gives you reference points. It widens the set of tools you can draw from when constraints tighten. Before we close this stretch, I want to ask you one last thing. If efficiency, sustainability, and nutrition were the only metrics that mattered, no branding, no tradition, no marketing, what foods do you think would disappear, and which ones would suddenly make a lot more sense? That question isn't hypothetical. It's the direction food conversations are already drifting, whether we notice or not. If you want to explore more resources or deeper dives into how these plants are being tested and used, you'll find them linked in the description. No pressure, just context for those who want to look beyond the surface. And if this kind of breakdown is useful to you, consider subscribing. Not for hype, but for clarity. Because understanding how systems really work is becoming just as important as understanding what is on your plate. The part most people miss when they talk about future food is that the future rarely arrives all at once. It creeps in through edge cases first, through overlooked solutions, through things that feel optional until they quietly aren't. Duckweed sits squarely in that category, not as a headline-grabbing replacement, but as a pressure-tested fallback that starts to matter when everything else gets more expensive, more fragile, and more constrained. What makes duckweed and similar aquatic plants uniquely valuable isn't just their nutrition. It is the fact that they decouple protein from the assumptions we've built entire systems around. No assumption that food must come from soil. No assumption that scale requires consolidation. No assumption that efficiency must be technologically complex. Once those assumptions fall apart, new paths open up very quickly. This is why these plants tend to reappear during moments of stress. War, drought, supply chain breakdowns. Closed environments, they don't need ideal conditions, they need consistency. And consistency is easier to maintain than perfection. There's also a quiet psychological shift that happens when people encounter something like duckweed. It forces a re-evaluation of what natural even means. We're comfortable with crops that look agricultural because we've normalized them. But agriculture itself is an intervention. Duckweed simply bypasses many of the steps we've layered on top of food production over centuries. And that's the uncomfortable truth. Many of the inefficiencies we defend aren't necessary, they're historical. They persist because they're familiar, not because they're optimal. None of this means duckweed is a cure-all. It has limitations. Flavor neutrality means it rarely shines on its own. Amino acid balance still benefits from combination with other foods. Processing standards matter. Overselling it would be just as irresponsible as ignoring it. The point isn't perfection. The point is relevance. When you strip away the hype and the resistance, what's left is a simple question. If a food source is safe, dense, scalable, and resource-light, how long can it remain invisible before necessity brings it into the open? History suggests not forever. And this is where I want to leave you with one final expert-level takeaway. Most breakthroughs don't fail because they don't work. They fail because they don't fit the story we're telling ourselves at the time. Duckweed doesn't match our story about protein, but stories change faster than biology does. Remember, it's not about chasing what's popular or rejecting what's familiar. It's about understanding what actually works under constraint. The people who see that early don't panic when conditions change, they adapt. If this video shifted how you think, even slightly, hit the like button. It helps more than you'd expect. If you want more deep dives like this, less hype, more reality, subscribe and check out the next video. It connects directly to this one, and it goes even deeper into how overlooked systems quietly shape the future long before they become mainstream. Because once you understand that efficiency doesn't need permission, you start seeing blind spots everywhere.